You know that feeling in a video game when you hit a wall and you realize you need some special key to unlock the next level? Well, believe it or not, mathematics has a key just like that. It's a number that was once dismissed as imaginary, but it turned out to be the key that unlocked entire new dimensions of science and technology. So let's meet this mysterious and powerful number, I.
Okay, so it all starts with a puzzle. For centuries, mathematicians felt pretty good about their toolkit. They had the real numbers, right? Everything on a number line, from way out in the negatives to way out in the positives. But they kept stumbling into this one specific problem, a locked door that their numbers just couldn't open.
And this is the locked door. It looks so simple. X squared equals -1. But just think about it for a second. What number, when you multiply it by itself, gives you a negative number? A positive times a positive, that's positive. A negative times a negative, that's also positive. See the problem? With the numbers we all know, this thing is totally unsolvable. It's a complete dead end. So, what if we just need a new kind of number? To get past this wall, mathematicians did something really, really bold. They didn't find a new number somewhere on the number line. They straight up invented one. They basically said, okay, the rules of this game are holding us back. Let's add a new piece to the board. And here it is. The new piece, a new number, the imaginary unit, which we call I. And it's defined by one simple, powerful rule. I squared equals -1. That's it. By just deciding that this is true, we now have an official square root for -1. This one move, this one little piece of creative genius, is the key that unlocks absolutely everything else.
So this new number has this really fascinating personality. When you start raising I to higher powers, it doesn't just get bigger and bigger, it cycles. Check this out. I to the first power is just I. I squared, well, we know that's -1. I cubed is -I, and I to the fourth brings us right back to 1. It's this perfect four-step loop. And it hints at something really profound. Every time we multiply by I, it's like we're making a 90-degree turn.
And that whole idea of a turn is absolutely crucial. Because if multiplying by I is a turn, well, you can't really turn on a straight line, can you? This means we've just broken out of the one-dimensional number line and into a second dimension. We've created a whole new space for numbers to live, the complex plane.
So, when we mix a real number with our new imaginary one, we get what's called a complex number. It looks like this, A plus BI. The A part is the real part, and the BI part is the imaginary part. Just think of them like coordinates on a map. The real part tells you how far to go left or right, and the imaginary part tells you how far to go up or down. Even a regular number, like 6, is technically a complex number. It's just 6 plus 0i. And this is what that map looks like. That horizontal line is our good old real number line. But now we have this new vertical line, the imaginary axis. So a number like, say, 3 plus 2i becomes a specific point. We just go 3 units over on the real axis and then 2 units up on the imaginary axis. And boom! Our abstract number is now a real, concrete location in space.
Okay, so we've built this entire new system. We have I. We have the complex plane. What was the point of all this again? Right. Let's go back to that problem that started this whole crazy journey.
Let's take an unsolvable problem, like x squared plus 9 equals 0. Using only real numbers, you hit a wall. But now, with I in our toolkit, it's easy. We just rearrange it to get x squared equals -9. Now when we take the square root, well, the square root of 9 is 3, and the square root of -1 is our new best friend, I. And just like that, the solutions are positive and -3i. The impossible equation is solved. It's that simple. Now every complex number has this little partner, called its conjugate. It's super simple. It's just its mirror image across the real axis. You just flip the sign of the imaginary part. So the conjugate of 3 plus 4i is just 3 minus 4i. And this little trick, well, it turns out to be incredibly useful.
And here is why that conjugate is so powerful. When you multiply any complex number by its conjugate, something magical happens. The imaginary parts perfectly cancel each other out, and you are always left with a pure, real number. It gives us a totally reliable way to get from the complex world back to the real world, which is a vital tool for all sorts of calculations.
So far, we've seen that I is a pretty clever tool for solving equations, but its real power its deepest, most profound beauty is in how it connects totally separate parts of the mathematical universe. So get ready, because we're about to look at what many people call the most beautiful formula in all of mathematics.
I want you to think of different fields of math, like algebra, geometry, trigonometry, as separate islands. For a long, long time, that's really how they felt. But I, the imaginary unit, is like the bridge that suddenly appeared and revealed that, wait a minute, these weren't separate islands at all. They were all part of the same continent.
And this is it, Euler's formula. It is just stunning. Look at this. On the left, you have E, this special number that's all about exponential growth. On the right, you have cosine and sine, the functions that describe waves and circles and rotations. And what's the bridge that connects the world of growth to the world of waves? It's I. It connects them. It's a connection that is as shocking as it is profound.
And this formula isn't just some abstract algebra, it's actual geometry. Hey, remember how we said multiplying by I felt like a rotation? Well, Euler's formula shows us that this is literally true. As you plug different values in for x, the formula perfectly traces out a circle on the complex plane. It basically says that exponential growth in the imaginary direction is rotation. Mind-blowing, right?
So at this point, you might be thinking, okay, this is all just really beautiful abstract theory. But here's the thing. The name imaginary is probably one of the biggest mistakes in the history of science. Let's see how the supposedly imaginary number is absolutely essential to building and understanding our very real physical world.
So where is this imaginary number hiding in the real world? Oh, it's everywhere. Literally everywhere. Think about electrical engineering. The alternating current that's powering your lights right now, it oscillates back and forth. Complex numbers are the perfect language to describe that oscillation. They make designing our entire power grid possible. The same goes for the radio waves that carry your phone signal, or the physics that describes quantum particles. Basically, anything in the universe that rotates, vibrates, or oscillates is being described using I.
When you get right down to it, what started as a clever trick to solve a nagging equation turned out to be a fundamental language for describing reality itself. The waves, the cycles, the rotations, all these patterns were always there in nature. We just had to invent an imaginary number to finally have the language to see them clearly.
The story of I really shows us that sometimes the biggest breakthroughs happen when we dare to imagine a new rule for reality. And it just makes you wonder, doesn't it? What impossible problems are we facing today that are just waiting for someone to invent a new number or a new idea to finally solve them? What's waiting for us just beyond the edge of what we currently call real?